What's up, guys? Are we ready to have some more fun on the craft? I'm just joking. No fun allowed here today. I wanted to make a quick video discussing something happening on Twitter. A few days ago, SpaceX announced their AI-1 satellite, an AI data center satellite built to bring compute to train AIs into orbit. Jerry from JerryRigEverything took issue with this in an interesting way. He makes a claim pertaining to thermodynamics, which, look, I, like many people, want to be true because it would inhibit this design from working. Unfortunately, this claim, when we quantify it, is factually incorrect. So we're gonna go through it and do the math, which is not very complicated, nor does it take very long. First, however, I need to say, we don't disagree. You and me, us and Jerry, we're all on the same page. I despise generative AI and I despise Elon Musk, and I think we have that in common. There are many reasons I would consider more than valid for both of these. Frankly, we're spoiled for choices, but we shouldn't let that cloud our logical judgment. I don't want freaking space AI data centers to happen any more than you do, but yelling physical inaccuracies from the top of one of the biggest soapboxes in the world only serves as an excuse for people to not take any tangible demonstrative action. So, what did Jerry tweet? Well, many things. God, so much. But this one started it. It's in response to an account relaying SpaceX's announcement, and the video includes some technical details about the satellite and some useless banter between Musk and some SpaceX employees. Jerry's response is as follows. You know the reason your Stanley or Hydro Flask is so good at keeping your water cold is because there's a vacuum inside the walls of the thermos. Heat can't conduct in a vacuum, and radiated heat is ineffective at the temperatures processors operate at. This satellite would be like plugging in your gaming PC without a CPU cooler. It'll be dead in minutes. Some of the comments on this post attempt to retort this, and most of them just add grok. But a lot of the counter-arguments boil down to the engineers at SpaceX are smarter than you, they've probably worked it out. And while that's obviously true, you're not gonna outsmart rocket scientists with something you learned from freaking oxygen not included, there's no reason we should settle for this argument. Ignoring for the moment the analogy to thermos bottles, which we will come back to, we're gonna focus on the central claim of this tweet. Radiated heat is ineffective at the temperatures processors operate at. This is a qualitative assessment. It seems safe to assume that ineffective means the amount of radiated energy is not sufficient to offset the produced thermal energy, which seems quantitative, right? Well, he takes into account temperature, yes, but the equation for thermal radiation has two more variables, emissivity and area. Yes, if you put a naked GPU in orbit, or hell, even in interstellar space, and run it, it will heat up to the point of malfunction. That's because it does not have enough area and is not emissive enough to reject the heat it generates. That would, indeed, be like plugging in your gaming PC without a CPU cooler. However, that's not what this satellite is. You would be excused for missing the huge radiator panels on the top and bottom of this satellite, so let's take those into account and do some math. The equation for thermal energy rejected by a gray body by radiation is this. Here we can see the variables. Inside the brackets, we have the temperatures of the surface and the surrounding space, and outside it, the area of the surface and epsilon, the emissivity. Sigma is the Stefan-Boltzmann constant, which is equal to about 5.7 times 10 to the negative 8th. Firstly, we rearrange the equation to solve for operating temperature to see if it exceeds that of market GPUs. Then we can plug in some variables. SpaceX discloses directly the wattage of the solar panels, which they say is about 150 kilowatts total, and the area of the radiator, which they say is about 110 square meters, which we gotta double because they have two sides. Now, when looking for a value for emissivity to use, I encountered some problems. Hemispherical emissivity for a material is technically a function of wavelength, so there's no one emissivity to go off of. When we use emissivity for these kinds of calculations, we have to take the average emissivity for the emission spectrum of a specified material at a specified temperature. My suspicion is that because this average is so specific, it's not useful enough to be documented in lots of industry literature. The only place I could find a value for emissivity is in this paper, where it's cited as 0.78. Using this value, the temperature of the radiator on the AI-1 satellite comes to about 79 degrees Celsius. That's pretty warm, it's towards the upper bounds, but it's still within operating temperatures for many consumer GPUs. So like I said, the math is not very difficult and it doesn't take very long. But you could say that we can't leave it at this. We have to consider Earthshine, and we have to consider the heat transfer between the satellite body and the radiator. And on the flip side, we must consider that it's not unheard of for there to be two loops, a cool loop and a hot loop, with a heat pump between them. This configuration does obviously make the satellite a little bit more complicated, but it has flight heritage, so it's not outside the bounds of reason. But the bottom line is that our starting point is within operational temperatures for GPUs, and additional considerations can easily be counteracted with not-so-new engineering solutions. Jerry does none of this math, and he phrases his argument as if temperatures would rocket well outside the reach of engineered solutions. Which is false. The GPUs on this satellite are most likely pretty chill. Now, let's talk about the thermos flask analogy. There's so many reasons it's dumb. Firstly, thermos flasks are obviously made with the explicit intent of maintaining the interior container's temperature. Not only does it do this by creating a vacuum, but it's a vacuum with exterior walls in the sometimes 300s of degrees Kelvin, completely incomparable to the vacuum of space. Secondly, because of these design requirements the thermos flask must fulfill, the interior container is obviously made with low emissivity and low area. A more proper comparison would be dipping the thermos in liquid hydrogen, adding fins to increase the surface area of the interior container, and making it out of something like niobium instead of freaking steel. And when you do that, suddenly it's not a very effective thermos anymore. Personally, I think that, and I think Jerry agrees, these satellites will do immeasurable harm to society in many different and new ways. Just because we don't want AI data centers on Earth doesn't mean it's automatically okay to build them in space. That's what I believe, but that doesn't mean it physically won't work. And it's extremely important to recognize that difference. We can't be running around using our misinformed understanding of physics as justification for apathy. Why should I take action by protesting when physics will take care of it? Jesus, take the wheel. No, that won't do. And this would be the end of it, if Jerry could shut his damn trap when he's wrong, but like any Twitter user would, he doubles down, retorting counter-arguments with, well, not even back of the napkin, no math at all, just made-up comparisons. So to end this video off, let's rapid-fire through a few of those and go through why they're misinformed. Starting with number one, when people bring up Starlink satellites to say that SpaceX has this figured out, he says, none of the Starlink satellites are AI ovens. They're not, but all the energy from Starlink's solar panels still needs to be re-emitted into space, which is about 35 kilowatts for a single satellite. That's not as much, but it's a little under a quarter of AI-1's production, so still a considerable amount. Furthermore, the ISS absolutely is an oven, and it keeps cool as a cucumber with decades-old technology. When people bring up the sink temperature of the vacuum in space, he says, is the array going to deep space now? The sink temperature is pretty irrelevant in low Earth orbit. Okay, so let's take Earth radiance into account then. Earth receives about 1.353 kilowatt per square meter of direct solar irradiance. It has to reflect or emit 100% of that energy in order to not skyrocket in temperature immediately. So if we calculate how much energy hits Earth and divide with the area of a sphere at the orbital altitude of the AI-1 satellites, which is about 700 kilometers above the surface, and multiply that with the maximum area the satellite exposes directly to Earth, we get something that looks like an increase in operational temperature of about 16.5 degrees Celsius. That's significant, but it is a liberal average, because it's only going to be this exposed to Earth at 2 points in its orbit, and this is also for a black body. This does make improvements in the radiator by either plumbing or material science mandatory, but it's still far from physically inhibitive. Now this one is the most ridiculous. He says each satellite would need a radiator the size of a football field. Please refer to the previous 9 minutes of this video. 110 square meters on a side is well within the territory of workable, and for the American mind, 110 square meters is a little over a 50th of a football field in area. And he also says the space station cost $150 billion. Oh, well, yeah, the ISS was launched on mostly the space shuttle, which is a vehicle built by dozens of contractors spread out over nearly an entire continent, all on cost-plus contracts with a government agency. This comparison is somehow even worse than the thermos bottle. And these last 2 points he repeats several times. Now, it's possible that by ineffective in the original tweet, Jerry doesn't mean non-functional, but infeasible in an economic sense. I can't speak to that at all, but if that's what he meant, I personally hope to God that he's right. I don't want AI data centers in space to work out. I don't want them to become a thing anybody does or is allowed to do. But as for the physics he brings up, none of it's absolutely inhibitive, not even for the concept render SpaceX shared. Today, as of recording, SpaceX is going public. This means that a lot more people are going to have a lot more to say about anything that happens, and none of these people will know what they're talking about. Jerry's post is one of the last fountains of bullshit in this space that can reasonably be refuted. From here on out, the flood of bullshit will be overpowering, and a lot of that bullshit will be spread by AIs trained on these very satellites, if they're ever allowed to be launched. The ball is in our court,